See this problem 1. If vector A equal to vector R divided by R cube, then delta D, del A is option A 0, option B 1 by R cube, option C del cube of R, option D 4 pi del cube of R. If this problem is given to you, automatically you can choose option A. It's a general proof available in our mathematical physics. Vector R divided by R cube is equal to 0. But that is not correct here, because they have given the answer in terms of Dirac delta function. Dirac delta function approaches 0 for all values except at R equal to 0. That means x equal to 0. In this problem, suppose the condition is given, that is R not equal to 0 condition is given, only at that situation del A equal to 0. But the problem is given without having any condition. At this stage, you have to choose the option D. 4 pi del cube of R is the value of del of A. Suppose the condition R not equal to 0 is included. If vector A equal to vector R by R cube, find the value of del A at R not equal to 0, then you may choose option A, 0. They have given without any condition. At this stage, this origin is also included. The surface includes the origin also, not away from the origin. Therefore, the option D is correct. 4 pi del cube of R is correct. Suppose the problem is asked with the condition of R not equal to 0, then the value of del A equal to 0. Now see the second problem. The Laplacian of a scalar field pi is, they are given 4 options. Automatically you may choose del square pi is equal to 0. That's not correct, because they have asked the value of Laplacian of a scalar field, not Laplacian equation. The Laplacian of a scalar field. Pi is a scalar. Del dot del is a Laplacian operator, del square. That means this operator is operating on pi. So the answer is dou square pi divided by dou x square plus dou square pi by dou y square plus dou square pi by dou z square. So the option B is correct. The Laplacian of a scalar field pi is dou square pi by dou x square plus dou square pi by dou square plus dou square pi by dou z square. Now see the third problem. If vector f is equal to a into I plus b into j plus c into k, then option A, del f is equal to 0. Option B, curl f is equal to 0. Option C, both A and B are correct. Option D, del f is equal to 0, but curl f is not equal to 0. First of all, we should understand the nature of the vector. It is a constant vector. A into I plus B into j plus c into k is a constant vector. If you take del f is I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot a into I plus b into j plus c into k is equal to dou a by dou x plus dou b by dou y plus dou c by dou z, which is equal to 0. So del f is equal to 0. This is our solenoidal condition. Next we have to take curl of del cross f. I j k dou by dou x dou by dou y, dou by dou z. A, B, C. If you take the curl value, that is also 0. So the given vector is both solenoidal and irrotational. Therefore option C is correct. Both solenoidal and irrotational. We will go to the fourth problem. For a vector field capital A, for a vector field A which identity is correct. Option A, div of curl A equal to 1. Option B, div of curl A equal to 0. Option C, curl of div A equal to 0. Option D, div of grade A equal to 0. We know that Gauss-Line magnetostatics, div B equal to 0, then B equal to curl A. We know that div B equal to 0. This is our Gauss-Line magnetostatics. Then B equal to curl A. Here A is our vector potential. So option B is correct. Now we go to the fifth problem. If a vector field if surface integral, see, right, the surface integral of a curve over a surface S bounded by a closed curve C is equal to option A dot dr, option B del dot A, option C A dot ds, then option D del square A d. See, the correct answer is option A, which are Stokes theorem. A dot dr is equal to curl A dot ds. We will discuss the rest of the things in the next lecture.